Hello everyone and welcome to the 347 lab in which we're going to be using a bracket and analyzing it. So what we're going to start off with is static structural, which is here to the left, and we're going to double click on that. Next, we want to right click on engineering data and select edit. And what we can see here in the top is structural steel. So this is the types of materials that we have available to us. Now, we don't want to just use structural steel, so if we go up to the top here to engineering data sources and select that, we'll see a bunch of other materials that are available to us. So we can select general materials here, and what we'll see here all of a sudden is a lot of other materials such as aluminum alloys, copper alloys, and titanium alloys. What I'm going to do is I'm going to select aluminum alloy by clicking the yellow plus button, and we should see a purple book appear to this, so which means it is now in our part library, so we can select it later. And I'm going to select titanium alloy as well. Next, what we're going to do is we're just going to close out of the tab by clicking X in the top here, going back to our project space. Next, what we're going to do is we're going to import our geometry. So I'm going to right click, import geometry, and you can click browse to find it on your computer. In my case, I already have it selected, so I can bring it up right here. So it's a bracket.igs. Next, what I'm going to do is I'm going to double click on the model, and this is going to open up our model space window. So I'm going to let that boot up real quick. All right, so we have our bracket here. So what we're going to do is we're going to click on mesh, go to sizing, and click on resolution. We're going to bump that up to 3. If we go up to 4, it will actually exceed the amount of nodes that we're allowed to use as students. So just keep it at 3. And then what we can do is we can just right click and we can generate mesh. So give that a moment. Let it generate. Perfect. So we have our mesh generated here. Next, what we're going to do is we're going to right click on static structural, insert, and we're going to insert 2 forces. So one more time. So we got force 1, force 2, and we're going to right click one more time, and we're going to insert in a fixed support. So let's start backwards. So let's click on fixed support. We're going to rotate down to the base of this, select the bottom face, and then go to geometry and select apply. So now we have our bottom face selected. Next, we're going to go to force 1. Force 1 is going to be the top face of our circle here. So we're going to select that face right here, go down to geometry, hit apply. Now we're going to go to magnitude. We're going to type in 1500, hit enter, and as we can see, it's ramping. What we can do is go over here underneath force, and where it says 0, we can highlight that area and type in 1500 as well. So that way we have a fixed 1500 across the board. Now we're going to click the direction of our force just to make sure that it is being applied straight down. And as you can see, we do have straight down force applied. So we're going to hit check. That's what we want. And we're all done with that force setup. So now with force 2, what we want to do is we want to apply a force that is from the side of the bearing cup that we see here. So what we're going to do is rotate this a little bit. I'm going to select this face here, and my computer is freezing up a little bit, so give it a moment. There we go. We can select apply. Oh, sorry, one more time. Click on that face and select apply. So we have the outside of that bearing cup selected. Now what we're going to do is we're going to do the same 1500 Newton force, and then we're going to go over here to the right again and type in 1500 as well, so that we have a set flat 1500. Next, what we're going to do is select direction. As we can see, we have a direction that is pointing inwards. That isn't what we want. So what we're going to do is we're going to select an edge that's going to be a reference. So it doesn't have to be exactly on the bearing cup itself. So what I'm going to do is I'm going to select an edge over here, and as you can see, the arrow is pointing now in a different direction. I'm going to select apply. As you can see, this arrow up here changes directions and is now pointing that way. So what we do is, one more time, if we want to select direction, we go down here, we select an edge that is in the direction that we would like it to go. As we can see, this red arrow is now pointing. Select apply, and it will make the change here for the bearing cup. So now we have a force pushing to the left here. Now that all we have left is the solution. So we're going to right click, we're going to select insert, we're going to do deformation, and we're going to do total. And we're going to right click, insert, stress, maximum principal stress. This is going to be the maximum stress within the part. And then lastly, we want to most likely add insert stress tool. And then we're going to do shear stress, if I recall. And then as you can see here, we're going to have a safety factor as well. So now if we click on solution, select solve, and let that run. And now it says done. So now what we can see is a total deformation, maximum principal, and safety factor. Now this doesn't show us all the information we want right off the bat. So something that can be helpful is if we go to result, we can select maximum and minimum. So this is where we can see the maximum and minimum in terms of total deformation, our max and min of our principal stress, as well as our factor of safety. And it also tells us right here in this graph on the side that 15 is our max and 4.3 is our minimum. Looking at the factor of safety tool, we can see areas in which there might be some issues. So anything, we're typically looking for red concentration spots. So what I'm going to do is I'm actually going to go and change the material now to a material that we want to use. So we're going to open up on the left here the materials tab. I'm going to select aluminum alloy, right click, and I'm going to say create material assignment. So we're going to select this. We're going to double click on our part, hold shift, and make sure we select the whole part here. All right, perfect. And we're going to say apply. So now this whole component is aluminum alloy. Now we're going to go back to solution. We're going to go to solve once again, and we're going to run those calculations. Now that we've done that, we can go select total deformation, so we can see how much this bracket is being deformed. So we can see that is being pushed to the left and being pushed down. We can see where our maximum principal stress is, which is going to be in this bottom left corner. And we see these other areas of red. So I'm going to pull up the safety factor here. And what we're going to see is these little green areas here. But if we go back to our maximum principal stress, we can see that we have a point of stress here. It's a little bit yellow. We also have a point of stress down here in the bottom, as well as in this corner here, and also on this back side a little bit here. Typically when we see these types of things, anything with a sharp corner is going to be a point of failure before anything with a curve. So as we can see here, everything is within an acceptable range. We have a minimum factor of safety of 4.9, but if we look at these areas that are a little bit green, these would be areas of interest to improve our design if we had a load that was larger, causing failure. So hopefully this was a good tutorial in terms of covering how to set up a bracket, how applying two forces, a fixed support to it, and then being able to set up total deformation, maximum principal stress, the safety of factor tool, as well as maximum and minimum to help you label things in the model. Thank you for listening, and have a good day.